Have you ever been in a car and just wished you could, I don't know, slide sideways into a parking spot? It sounds so simple, right? But that one little wish actually points to a huge limitation in how most things get around. Well, today, we're diving into the amazing robotic tech that shatters that limit, unlocking a kind of movement that feels like it's straight out of science fiction.
Come on, we've all been there. You're trying to parallel park on a busy street, and the space is just impossibly small. Or maybe you're wrestling a new couch through a narrow hallway. You just wish you could nudge it sideways an inch. Well, what if I told you that in the world of robotics, they've already solved this exact problem?
So here's how we're going to break it all down. First, we'll look at why movement is a problem in the first place. Then we'll define what a holonomic robot actually is. After that, we get to the cool part, the secret engineering that makes it all possible. We'll see where it's being used out in the real world, talk about the downsides, and then peek into the future of this superfluid motion.
Okay, so let's dig into that core issue. The reason your car can't just slide over is because it's what engineers call non-holonomic. Now that's a fancy term, but the idea is really simple. Its movement is constrained. It's kind of stuck on rails, so to speak. And this really shows you the difference. On one side, you have the car. It can go forward, it can go back, it can turn in a curve, but that's it. It cannot just decide to move directly to the right. But then, look at the other side. This is the ideal holonomic mover. It's a free agent. It can move forward, sideways, and rotate, and it can do all of those things at the exact same time. That, my friends, is total freedom.
So that brings us right to our star of the show, the holonomic robot. What does that word actually mean? Well, it's the name for the technology that finally achieves that ideal, totally free movement we were just talking about.
Okay, I know, that definition looks a little intense, but let me translate it for you, because the idea is actually beautiful. All it really means is that if there's a way the robot can move, you have a direct control for it. No compromises, no awkward Austin Power-style three-point turns. You think move left, and it just moves left.
So to really get this, we need to quickly talk about degrees of freedom. It's simpler than it sounds. For any robot on a flat surface like the floor, there are only three basic ways it can move. It can shuffle side to side, that's the x-axis. It can move forward and back, that's the y-axis. And it can spin in place, like a top. That's rotation.
And boom, this table just lays it all out perfectly. Look at the non-holonomic row. That's your car. It gets a big fat no for direct sideways motion. And yeah, it can rotate, but it's not truly independent. It has to be moving forward to really turn. But now look at the holonomic row. It's just green lights all the way. Yes, yes, and yes. Full, independent control over everything.
So how in the world is this possible? It feels like it breaks the rules of how a wheel is supposed to work, right? Well, it's not magic, it's just some seriously clever engineering. The whole secret is in a very special kind of wheel.
Meet the omnidirectional wheel. It looks kind of wild, doesn't it? You've got the main wheel itself, but it has all these smaller rollers lined up along its edge. And those little guys are the secret sauce. They're designed to let the wheel slide sideways with almost zero effort, while the main wheel is still pushing forward or backward. It's a wheel that's designed to both grip and slip, perfectly on command.
And here's how that translates into that crazy movement we saw. If you spin all the wheels the same way, the robot just rolls forward. Easy enough. But to slide sideways, the wheels on one side spin inward, and the wheels on the other side also spin inward, forcing the whole robot to slide on those little rollers. To spin on a dime, you just rotate the wheels in opposite directions. But the real mind-bending part is when a smart controller starts mixing all of these motions at once. It can move diagonally while spinning. It's like a perfectly choreographed robot dance. This is all incredibly cool, but let's get real. Where is this actually useful? Let's take a look at the places where this incredible agility becomes a total game changer.
Okay, picture a massive, cluttered warehouse. A holonomic robot can slide into a super narrow aisle without needing a huge turning radius. That saves tons of time and space. Or imagine a robot in a busy hospital hallway. It can just glide around people and equipment without having to do a clumsy back up and turn maneuver. In a research lab, you can position something with microscopic precision. This agility isn't just a cool trick, it's a massive boost to efficiency.
And this is especially true in a place like a robotics competition. I mean, the ability to instantly dodge, strafe, and reposition on the fly, that's not just neat, that's a decisive strategic advantage. It's something a normal robot just can't compete with.
But you know, this incredible freedom doesn't come for free. Like any highly specialized piece of technology, these holonomic systems come with some pretty important trade-offs you have to consider.
The advantages are super clear. Agility that's off the charts and crazy high precision. But on the flip side, those complex Omni wheels are more expensive and need more maintenance than a simple wheel. The computer programs needed to coordinate them are, as you can imagine, really complex. And because of those rollers, they can sometimes slip on slick or uneven surfaces. So, it's a very specific tool for jobs that need its unique skills.
So let's wrap this all up. What does this technology really mean for the future? How does changing something as fundamental as movement affect the robots of tomorrow?
At the end of the day, it all boils down to this. Total control gives you ultimate agility. And this isn't just a small upgrade. We are talking about a fundamental shift in how robots can exist and operate in our world, in our spaces. They can be more graceful, more efficient, and just more intuitive than ever before.
And that leaves us with one last thing to think about. As we see more and more robots in our homes, our workplaces, and our cities, where do you think this complete freedom of movement is going to make the biggest splash? In the delivery drones flying overhead, the personal assistant robots in our homes, or somewhere we haven't even thought of yet? It's a future that is quite literally moving in all directions. Thanks for watching.